Okay, so again, this is another CRT, Chinese remainder theorem. I did one in another video, but this is another question from the second assessment. There was two assessments with two different questions on there. So just to go through this one, we're looking for solution x, which is congruent to 2 mod 11 and also congruent to 5 mod 27. So I'm going to take my big modulus, which is 11 times 27, and that's equal to 270 and 27 is 297. Okay, so M1 then will be 297 divided by the 11, which has got to be 27, and M2 is going to be the 297 divided by 27, which is 11. Basically, when there's two, they're going to be opposites. Remember, when there's three, if there was three numbers there, then the M1 for this one would be these two multiplied by each other, and then the middle one would be the first by the third, and the third one would be the first by the second, and so on. But for only two, it's even easier. They're just the opposites. Okay, the residuals or remainders are we can just read straight off. R1 is 2, and R2 is 5. There. And then we need the solution to the congruence equations. Remember, so I've got to have is S1. So I start with this number here, 27 times S1 is congruent to, instead of 2 mod 11, it's going to be congruent to 1 mod 11. Okay, so I need a solution to this. I'll just do this first and then go on to the second congruence equation. So because I'm working mod 11, I can reduce the 27 mod 11. So 11 goes into 22 and leaves 5 over. So 5S1 is congruent to 1 mod 11. So the answer is somewhere between 1 and 10. It's never the 1, so it's between 2 and 10. So I need a number that I can multiply by 5. And when I divide by 11, I get a remainder of 1. So like I want something that goes into like 5 times something is either 12, or 5 times something is 23, or 5 times something is 34, or 5 times something is 45. Right? Obviously 45 would be good. 5 nines would be 45, and 11 goes into 44. So S1 is 9. Okay, that's the doing it in your head method. I'll do the second one, not in my head, if you know what I mean. I'll do the extended Euclidean algorithm. So we can see how that method works as well. So the second congruence equation will be, I'll take the 11. So it's 11S2 is congruent to, instead of 5 mod 27, it's going to be congruent to 1 mod 27. Okay, remember that. You always change these numbers to 1 when we're doing the congruence equations. The next thing is mod 27 is not really helping us to reduce much there. So we will do the extended Euclidean algorithm. So I'll start off, 27 equals 2 times 11, which is 22 plus 5. 11 equals 2 times 5 plus 1. Okay, so that went down nice and quick. And we'll do that, the opposite of that, to get the thing. I'll put a little bit of room here. So I start with the 1. So 1 equals 111 minus 2 5s. I'm going to replace the 5 next. So the 5 is equal to 27 minus 2 11s. So that equals to 111 minus twice 27 minus 2 11s. 27 minus 2 11s. Okay, so when we tidy that up, I get that's 4. So it's 4 11s, and 1 11 makes 5 11s. 5 11s minus 2 27s. Okay, so that seemed fairly straightforward. That's 55, that's 54. So 27 inverse, then it's the inverse of 27 we want. So 27 inverse equals minus 2, okay, the coefficient there. And minus 2, we're working mod 11. I'm going to add 11 on, is 9 as well. Okay, so I'm not sure if that's... Am I right what I'm doing here? No, we have a mistake somewhere along the way. Let me just double check. 11 mod 27. So 27 is 2 11s plus 5. 11 is 2 5s plus 1. Okay, so 1 is 111 minus 2 5s is 111 minus 2 27s minus 2 11s. So that's plus there. So it's 5 11s minus 2 27s. can see where I went wrong. Sorry about this. It's not the, I was looking, when I was saying I was getting the inverse of 27, I looked at this question and saw the 27, I'm actually getting the inverse of 11. So the inverse of 11 is 5. Sorry. 11 inverse is 5. When I was looking at what's the 27, and because it's so bloody condensed on these little boards, I just looked at that one by mistake. It's that one there I'm getting the inverse of, so S2. So 11 inverse is 5, so that's S2. Okay? Right, so to finish this one out, what have I got? The x is equal to the sum from I equals 1 to 2 of the mi or isi. So it's the modulus is by the residuals or remainders by the s solutions to the equations. So it's going to be, put down the moduli, it's 27 and 11, so 27 there, 11 there. The ors are 2 and 5. And the solutions to the two equations are 9 and 5. Okay, so this is the next thing, is just to multiply these out and finish it off. 27 by 18 is 486 plus 11 by 25 is 275. That's equal to 761. Okay, and we can reduce that, our big mod, which is 297. So just take off a couple of 297s and I'm getting the answer is 167. So we're saying is 167 is congruent to 2 mod 11. Okay, and 167 is congruent to 5 mod 27. So the quickest way to check that is I'll just subtract the 2 and see does 11 go into the other bit. So if there was a remainder of 2, it means 11 should go into 165. So 165 divided by 11, it goes in evenly 15 times. And if there's a remainder of 5 when I divide by 27, it means 27 should go into 162. So 162 divided by 27 is 6. So that's our answer, 167. Sorry about the mistakes in the middle, but that's just par for the course. I don't have any video editing software, so I can't edit them out, or I can start again, but I am not doing that.